Welcome to Jet Mathematics with your host, Milton Ebiwari John. Today we are looking at factorizing quadratic expressions that are perfect squares. Factorizing quadratic expressions that are perfect squares. Now there are two rules we have on the board. The first one says the square of the sum of two terms is equal to the sum of their squares plus twice their product. That is, we say if we have the sum of two terms all squared, then our result will be the sum of the squares of each of the terms plus 2 times the product of the terms A, B. If you expand this, as we did in our previous classes, you are going to get this result. That implies if we factorize this, we are going to get this. We already know how to factorize, but we will not go through the rigorous process we had in our last class. We will just use the theory and factorize things that are in this form. We call this form the perfect square of a quadratic expression. So once you notice that the first term can be expressed as a square, and the last term can be expressed as a square, and the middle term is 2 times the first term and the last term, then you can just factorize it and get the result as this. We'll see some examples on the board shortly. We also have the square of the difference of two terms is equal to the sum of their squares minus twice their product. The same thing, if we have a minus b all squared, then we're going to get a squared plus b squared minus 2ab. So if you can express any quadratic expression in this form, then the factor will become this. Once you can express a quadratic expression to look like this form, then I will repeat, your factors will become like this. Is that taken? Alright. So we apply these two in solving the problems on the board. But nonetheless, you can use the method we employed in our last video of factorizing quadratic expression. If you apply that method, you also get the result. But this is a bit fast and quick. It's quicker. So we have solution. We have a squared plus 12h plus 36. I'm going to see if I can express it in this form, but we have plus plus all through. So I'm going to see if I can express it in this form. If I can, then my factor will become this. So this is the a squared, already squared, and this I can write as c squared. Good. C squared is 36. That's already a squared. Good. And then I can express this middle term as 2 times h times 6. Wow. The middle term is 2 times h times 6. 2 times 6 is 12 times h is 12. h. So this is satisfying this first rule. It's satisfying this first rule. A square, B square, then 2 times A times B. It's satisfying this first rule. So the factor would look like this. It's satisfying the first rule there. So our final answer will become h plus 6 or squared. That's all. If you expand this, you are going to get this. Okay? So it's a very quick one and straightforward. Let's apply the same knowledge in solving example 2. Example 2 says we should factorize 5s squared minus 30xy plus 9y squared. We're going to use the same method. So here, because I can express 25 as 5, I can express it as 5 squared, and here x squared minus, I'll leave it as my 30xy first, plus I can express it as 3 squared and y squared. 3 squared is 9, y squared is 3 that. Then in indices we can write this as 5s all squared in indices, so that the square is affecting x and it's affecting 5. And we can write this as 3y all squared. Okay? Now we can express the middle term as minus 2 times 5x. Let me use dot product for better understanding. 2 times 5s times 3y. So you see that this is satisfying the second rule. The second rule here says a squared b squared minus 2 times a times b. Okay? So we have this like our a, this like our b, and this is minus 2 times a times b. So because it's satisfying that, our factors become 5x minus, satisfying this is minus 3y all squared. All squared. So this is the solution to this. Okay? If you have any question, you can drop at the comment section. But remember, you can use the traditional method we taught in our last video on factorization of quadratic expression. We can also employ them in factorizing this. But this is just a short way of factorizing quadratic expressions that are perfect squares. So do not forget to share this video, to comment, and to like.